Okay, once again, one wire interface. This is also one type of bus used for transmission of your signal. Apart from transmitting your signal, you are able also to pass through the power in this one. Okay, so this is about this one wire interface. So we will see what are its specification, what are its features. So one wire interface is an asynchronous half duplex communication protocol developed by Maxim Dallas Semiconductor. So one of the company, a reputed company which has been manufacturing this device. Right? It is also known as Dallas one wire protocol. It makes use of one single line, one single wire called DQ for communication and follows the master slave communication model. Okay, so it does whatever the earlier buses used to do. Okay, it will do all its functionality, but apart from that one of the key feature of one wire bus is that it allows power to be sent along the signal wire as well. Right, so that is the advantage. So you can understand, so instead of two cables, we have one cable which will perform transmitting of the data and also it is supplying the power. So how best it will be, right? So two device or two wires are not required. One wire is sufficient. That is the advantage which we have. The slave devices incorporated internal capacitor typically of the order of 800 picofarad farad to power the device from the signal line. So if I want to have one wire, so which is going to be charging at this part, so you have to have the a capacitor in order to store the power, right? Charge making. So you will be giving a order of 800 picofarad. Right? That is the size of that capacity for charging the device. The one wire interface supports a single master and one or more slave devices on the bus. So at a time I can transmit one to one or it can transmit one to multi point. So that is also one of the advantage. Earlier we were having only one to one type of a communication. One is master, one is slave. Now here one master and one or more slave is possible. Right. So this is a block diagram of the one wire interface. So again you can have, there is only one port number indicating so to which you wanted to transmit. So here you can observe that it is passing through this DQ and this DQ is also given and you are giving the power supply. So there is some change over here. So this port value it will be enabling to this part as well as to this part and as well as to this part. So at a time you are able to take. So that is why there is no more wire connection present here. Okay. So slave 1, slave 2, example he is taken this processors. Okay. So battery monitor IC and he has taken bit EE Pro. So at a time he is able to transmit the data. Okay. So still further going with this what wire one wire interface will be. So every one wire device contains a globally unique 64 identification number stored within it. So for transmitting the data or recognizing the different say identification of the receiver, so you should require some address value and that address value is going to stored in this 64-bit identification number, right? This unique identification number can be used for addressing individual device present on the bus in case there are multiple slave devices connected in a one wire bus. The identifier has three parts, a 8-bit family code, a 48-bit serial number and a 8-bit CRC. So this is a name how you have to queue for a one wire interface. So 8-bit family code value you should give, a 48-bit serial number representing the device and you should give 8-bit CRC. So cyclic redundancy check. So it is going to check any error bit is present or down, right? And it is forming of the 56 bits and computed from the first 56 bit. So these are all specification of a one wire interface. So how you are going to read data, how you are going to write data, because that is an operation or signal which you are going to give, right? So how you are making it active and how you are selecting the device and how you are transmitting. So for all those six, this is a sequence of operation for communicating with a one wire slave device is listed below. So I want to communicate, the master is communicating, I want to listen or I wanted to take that data. So these are the sequence which we need to follow, or the steps which we need to follow. So the master divides sets a reset pulse on the one wire bus. So reset pulse means indicating it will set a 0. So then what happens? The slave device present on the bus responds with a presence pulse. So you are indicating that I am present here. So you can transmit your data. So the master device sets a ROM command, net address command followed by the 64-bit address of the device. So these are the information he will give, right? So this he has to recognize this slave. Then if he is okay, then he is able to transmit the data. So this address the slave device to which it wants to initiate a communication. So multiple is there. So multiple people, this is just like in a classroom. If I ask a question, if multiple people raise their hand, so then there is an option for me to select and to ask the person or the student to answer it. So in this similar way, we are following this. The master device sends a read or write function command to read or write the internal memory or register of this slave device. So I will be sending what type of command I am giving. I wanted to read the data or I wanted to write the data. So you communicate with this slave device. So he responds with his memory, and from that we can access the memory and we can write the data at this slave, or we can read the data from the memory. That is the thing here. So the master initiate a read data or write data from the device or to the device, because it is a half duplex but two-way communication. It is possible. Right? All communication over the one wire bus is master initiated. So every time when you want to communicate to the other devices, it should be initiated by the master, right? It cannot be initiated by the slave. So it is just like a running a classroom. So I need to start the session. But you observe that if the time is there, this tool, it will allow you to log in into the session. Correct? This tool allows you to log in into the session. Even I am the organizer, but you people can join without me also. Right? But the thing here is that you will be as a presenter, you will be not as a organizer. So for few apps, if you tell, if the organizer it is not present, so the session will not start. So that is a different thing which you can observe with this tool and that tool. So this is also an embedded system, but it is with respect to only a virtual type. Okay, it is not the hardware type which is present. But to implement this, there will be hardware which will be located into that company, not here or with me. It is a thing which will be present here. Right. So the communication over the one wire bus is divided into time slots of 60 microseconds. So whatever data you are going to transmit or receive, it is divided into a time slot, and time slot's validity is for 60 microsecond. Okay, that is the specification. The reset pulse occupied 8 time slots. For starting a communication, the master asserts the reset pulse by pulling a wire bus slow for at least 8 time slots. So obviously it is going to take around 480 microsecond to start the communication. Okay, so here also I have scheduled for 9:55, but I have waited around for 5 minutes. Around 10 o'clock I started this session, because I am indicating, I am putting a message and everything. I am also not telling that you have not uploaded, you are attending the other session. So from that you cannot log out, so only there was a delay. Right? So whenever I wanted to transmit data in this one wire interface, I have to minimally wait for 480 microsecond because it will initialize the communication, because it will indicate that I wanted to start the communication. That is the meaning. If a slave device is present on the bus and is ready for communication, it should respond to the buzzer with a presence pulse within 60 microsecond of the release of the reset pulse by the master. Okay, so you can observe that within 60 microsecond, I should get a response. Otherwise, what happens? He is not able to transmit the data. Right. So in the real time, it will take some amount of time, right? But theoretically or device specification, you should get a response by that time. Otherwise, it will not do. The slave devices responds with a presence pulse by pulling a one wire bus low for a minimum of one time slot, which is 60 microsecond. So what slot it will take for it to communicate the data. Right. For writing a bit value on one of the one wire bus, the bus master pulls the bus for 1 to 15 microsecond and then releases the bus for the rest of the time slot. So you can understand that. So 15 microsecond, he will give the slots for indicating that I wanted to rewrite the data. Right. So it is initialization is started. It will take 480. Response you will get in 1 microsecond, sorry, 60 microsecond or one time slot, and you can respond to the slave I wanted to write the data by this amount of time. So this is how they have fixed the slots. Okay, so you may be asking, sir, why time slot is important for transmitting the data? Why it can't be left as it is? So you can observe that if I give a deadline to you or intimate to you, this is a deadline. So you people at least around 70 to 80% they have submitted the assignment yesterday which I have given. Okay. And if I make a quiz also, what happened? So I should give the deadline. Otherwise, what happens? If I don't give the deadline, so you will think tomorrow I will do, tomorrow I will do. So till your exam last also, till our exam completes also, they will not submit the assignment, right? So we have to give the deadlines because it is a time prayer. Time it is important for you also, time it is important for me also, right? I cannot wait for today. I will do two evaluation, tomorrow if you submit then I will do. So it should not be of that kind, right? So for all these things, this giving a time allocation is very much important. And here it is not only giving a deadline, okay, it is indicating what type of operation also it will take place. If I wanted to start the initialization, so what is the operations or how much time it will take? If I wanted to initialize for the read write operation, so how much time it will take? If I want a response from the slave, so how much time it will take? So these are the things which will be present. So if it is for the write in these condition, the for read condition it will be of reverse. So you can see the master pulls of a low. So here it is high and here it is a low. If the slave wants to send a bit 1 in response to the read request from the master, it simply releases the bus for the rest of the type slot. If the slave wants to set a bit value 0, it pulls the low for the rest of the type slot. So these are the condition which you can observe in the one wire interface. So here also you have all the specification, block diagram, features, right, how you are communicating the things with the slave. So everything he has explained with respect to the one wire interface. So next is what? Till now we were discussing about only the serial type of a communication. Okay. So one is active, he is transmitting the data. He is active, I will transmit the data. So parallelly we are not doing. So what is the advantage of doing parallel interface? So your task will be completed very soon. Okay, that is the advantage which you can observe in this. Okay, so for those type of thing we have parallel interface. Okay, the onboard parallel interface is normally used for communicating with the peripheral device which are memory mapped to the host of the system. The host processor controller of the embedded system contains a parallel bus, and the device which supports parallel bus can directly connect to the bus system. So how we are going to achieve parallel communication with respect to the device? So how it is possible for us to transmit the data, right? So you observe, I will take example of the Facebook. Okay, Facebook you take, or Instagram you take, or whichever you take. So when they are going for the live, example, if I wanted to conduct any meeting or session, right, or I want to be live, Facebook live or Instagram live. So what happens? I have to go there, click there, and I have to schedule and everything. And those information will be reached to how many people? Whether everyone will listen to whether I am live or not. So you will tell that, so he is my favorite actor or he is my favorite sports person, so I am following him. So if he is in live, so I will be notified that he is in live, I can observe it. Okay, the few of the scenarios for the extreme cases, like Prime Minister of India, right? Modi, he want to come for the live. So I am not following him or not a follower of his in the Facebook or Instagram, but still I am going to get a message that so Prime Minister Modi is in live and he want to speak about these things, so I can join that one. So your sending a message priority is been changed completely. Okay, even if I'm not interested also, I'm going to get that information. Okay, this is common thing which will be there, so which we call emergency type. So even if in my mobile phone, if there is no currency, right, I can still make a call for the emergency number. Okay, and don't try this one. Okay, don't try this. Sarah said me, if no currency is there, I will be able to make a call to this emergency number. Usually, emergency number for the police and for the medical thing, you don't require any money in your wallet. Okay, the mobile phone. Okay, you can directly call them, it will reach. Okay, but don't try this one because there are priority changes which has been done. Okay, similarly I am speaking with this parallel interface. Why I am telling this example? Because your communication have been transmitted parallelly to the n number of devices. So how we are going to achieve this? What is the process involved in? So those six we will be learning now. So the communication through the parallel bus is controlled by the control signal interface between the device and the host. The control signals for communication includes read-write signal and device select signal. So it is all dependent for the parallel device. Important thing is the control signal. So the control signal, it will be an important factor in the parallel communication. The device normally contains a device select line, and the device become active only when this line is asserted by the host processor. So now everything it is given with the organizer for this session. So if I wanted to mute you, if I wanted to unmute you, so all command is with respect to the organizer. You may tell, sir, I can unmute myself. That is a instruction which I have given to the software, that you allow the participant to unmute themselves. So why I am giving that option? Because if any questions is there or some technical issues is there, if I am not able to, my mic is not working. Okay, so I will be speaking. So I will be not aware that it is not been listening by you, or it is not reached to you. Okay, there may be some issues. So if these kind of issues are there, I want you to unmute yourself and you need to intimate me. So if suddenly the screen goes, so I will be teaching, I will be not aware. So you people, you should unmute them and tell that, sir, screen is not visible, right? So for positive things, you have to unmute it, for not for the negative part. Okay. So again, it is with respect to the controller. As I said, it is with respect to the organizer. So I can make a condition in the tool itself. I don't want anyone to unmute. I don't want anyone to share their screen. I don't want anyone to turn on their videos. Every control it is provided to me. but what is required, I am utilizing that one. Okay, other things I am not bothered about. That is the control. So those are all controls are there with respect to the organizer, right? So if you become an organizer, so you also will be having those controls, right? If you are a presenter, so what is a presenter specification or feature, so that you need to follow it. Okay, so only the host processor has control over the read and write over the control signal, right? The device is normally memory mapped to the host processor and a range of addresses is assigned to it. So the device is normally memory mapped to the host processor. Means everything it is controlled by the host, right? So now you observe the sessions which I will do. So if I wanted to create a file, I created a file, a folder. So you are allowed to delete the thing, correct? You are allowed to delete the thing. But if I make a condition that only for read purpose you should use, right? So here what happens, whatever data it is storing, it is stored into my server. I am not going to store the data or read the data from your memory. So I have created this session, I have created as an organizer, so all memory access will be for my from my memory, not from this slave memory. That is the meaning what is highlighted here. An address decoder circuit is used for generating the chip select signal for the devices. So you may ask, sir, why it is chip select required? So it is parallel devices, right? So all devices will be there. So all people will be present, but I don't want for everyone to receive the data. I want only the selected people to be data, and selected people can be one, or selected people can be 10 people. Okay, that is the reason. When the address selected by the processor is within the range assigned for the device, the decoder circuit activates the chip select line and thereby device become active and you can transmit your data. One second. Okay. The processor then can read or write from or to the device by ascending the corresponding control line. So you can see RD and WR, right? So front slash we can use for transmitting our data what we are transmitting to the multiple devices parallelly. That is the meaning. So this is a parallel interface device. So you can observe there is a host and there are multiple devices. Okay. So address line is been selected, right? So this address lines will select for the address decoder. Then we have a chip select. Then we have a operation select here. So whether read data, whether write data, and this is the data buses which is present here, which will be used for the peripherals, and you can able to transfer the things. So decoder circuit for your host and for the devices, these control signals are mandatory. So this is simple block diagram for a parallel interface which we can observe. Okay, so parallel communication is a host processor initiated. If the device wants to initiate and communicate, it can inform the same to the processor, right? If the device wants to initiate the communication, it can inform the same to the processor through interrupts. For this, the interrupt lines of the device is connected to the interrupt lines of the processor, and the corresponding interrupt is enabled in the host processor. So if anybody wants to intimate to me or interact to me, so they can unmute with one, they can chat. This is how one more peripheral we can have here. So you can WhatsApp me there or you can call me there. So you can use this multiple thick for the transmission. That is what is trying to tell. The width of the parallel interface is determined by the data bus and the host processor. So it can be a 4-bit, 8-bit, 16-bit, 32-bit or 64-bit. The bus weight supported by this device should be same as that of the host processor. So parallel data communication offers the highest speed for data transfer. Right. So next there are few different types of interfaces. There were all internal type or onboard bus interfaces which were present. Onboard in the sense indicating that device itself was having these interfaces, right? The buses and everything, there would be a cable at which we could have done. But these are external communication interfaces. Okay, these are your external communication interfaces, but some other technology which you are going to use for your device. It can be a wired one and it can be a wireless one. Now wired part, you can observe the Rs232, Rs485, USB, IEEE level 1394 firmware. So these are all your wired technology. And your wireless technology, you will be learning about infrared technology, Bluetooth technology, Wi-Fi technology, Zigbee technology, and GPRS technology. So you have observed these things in your real time, right? So I am using my laptop. I am connecting I am using this Ethernet cable for my internet connection. So that is a wired communication bus which I am going to use. So I have connected my earbuds to my mobile phone. So I am using a concept of Bluetooth. By remote control for the television, it is controlled by the infrared. Okay, my internet connected to my laptop is through my Wi-Fi hotspot. So Zigbee I have not used in my time. For my applications, we will be using that Zigbee application. So GPRS, it is globally known to you what operation it will do, right? Which is your nothing but your internet which is going to be connected. So these are the different types of external communication interfaces which we have, right? So we will be discussing each one of these which is present in this slide. Okay, so we'll start with external communication interfaces. So RS232C and RS485. So RS is nothing but your recommended standard number 232 and revision is C is a legacy full duplex wired asynchronous serial communication interfaces. So RS232, see what it is a full form. Recommended standard number 232 and revision it is C. So what type of communication it will do? It is a wire type. So it is a full duplex type. It is a asynchronous serial communication. So you can have a cable and you can connect to your device and you can transmit your data. That is the meaning here what is trying to address. The RS232 interface was developed by the Electronics Industries Association during the early 1960s. The RS232 extends UART communication signal for external data. So UART uses this standard TTL or CMOS technology for transmitting the power supply for bit, what it should be, the standard value, the space value. So everything he has listed in these 3 points. So I think there is a image. This is the image which is present. So the RS232 interface defines various handshaking and control signal. Here handshaking indicating that how you are going to communicate with, how you are going to establish a link. First thing is that if there are two devices, they want to communicate to each other. So how they are going to do? So I am one device, you are other device. Okay. So how we are communicating with each other? So we are communicating with each other through this app, right, which is Microsoft Teams. So here 50 people are present and I am speaking. So my voice is going to this 50 people, right, at a time, which is going, which is parallelly. Right. I want to make one people. I want to talk. So I'll make a call and I will speak. So how we are going to initialize this communication? So we will start with hello. Right. We will start with my name is so and so. Then we will introduce, then we will start. And one more important thing is that what language you are going to use. So if I speak English, so you will be able to understand. So if I speak in my mother tongue, out of these 50 people, hardly around 5 or 6 people will be understanding my mother tongue. Right. If I speak in Kannada also, so 50 people, around 40 people they will be understanding, around 10 people they will be not understanding, because they have migrated from other place. Okay, so the mutual understand between you and me, or the mutual agreement between you and VTU and faculty and VTU, that I wanted to teach, or I am able to teach only in the medium of English, so that everyone will understand. That is a common. You may be asking, sir, we don't know English also, right? But that we cannot do, because you have agreed upon. You have agreed upon with all the conditions, and you have taken this seat in this video. So there is no option of that. You have to learn that one. I cannot change my language to the regional language, because it will be what we call injustice to the other people who have migrated the thing. Nor I can use their language. So this is my mother tongue, I will use this one. That is not possible. That is not ethical. Okay. So handshaking is of these three. In the computer communication network, we call this handshaking. Okay. So there are three types of handshaking which we are going to do. First is what? Request permission. Second is what? uh, agreement between the transmitter and the receiver. Okay, I am ready to transmit, like agreement we should do. And later part, you are going to transmit the data. Okay, this is one type of handshaking. What is the another type? Okay, you have transmitted all your data. The data acknowledgement should be done by the receiver. So that should be done. So after successful transmission of the data, I have to end the correction. Okay, I have to stop the correction, right? I want to end the correction, so that I have to do. Otherwise what happens, this session will be continued lifelong if I don't close that one. So correction establishment, correction data communication, then correction termination. So these are the three major handshaking signals which we have to control your information from a transmitter to a receiver. Okay, and see, you can observe here, define various handshaking and control signal for communication apart from the transmitted and receive signal for data communication, right? So RS232 supports two different types of characters. So DB9, it is a 9-pin character, and DB25, it is a 25-pin character. So this is DB9 and this is a DB25. So it is a female type of a character which you can observe here, right? So these are the two types. Maybe this you are using for correcting the projector. Okay, and this pin you are using for correcting to your device. Maybe for the FPGA kit which I have seen, the cable I had used, so I use this cable, right? So which is DB25. So there will be a 25 holes or pins present provided from the device, so that you will be used for communication. Observe, it is a serial type of a communication. Okay, it is a serial type of a communication, and in the FPGA kit also we were giving master slave communication type. So now you will be understanding that devices, how this they have figured it out, or how we are transmitting the data, right? So the pin details of a two characters are explained here. So I'll just zoom in. So you can see these are the different part. Okay, so pin number 3, it is for transmission data. Pin number 2, it is for receiver data. Pin number 7 is request to send. Pin number 8, it is clear to send. Pin number 6 is data set ready. Pin number 5, it is for ground. Pin number 1 is for data carrier detect. Pin number 4, it is for data terminal ready. Pin number 9, it is for ring indicator. Then we have frame count, secondary DCD. So are multiple in there, and few of the ports are not connected, no connection. So if there is no connection present here, right? So why we are using those bits in future? If we are having in the future, if you get any of the types, so you can utilize that one. You observe that this pin number I spoke with respect to DB9. Similarly for DB25, these are the pin specification. Okay, so these are the things which you should do. Okay, So in detail again is I think same slave slide only, again it is been elaborated here, not elaborated, it is zoomed in. Mostly they might have not visible this screen, so they have taken into this picture. So now it is visible, I hope, right? So 9 pins, here it is 25 pins. So these are no correction, it is used for the future purpose, right? Rs232, it is a point-to-point communication interface with the device involved with are called data terminal equipment or data communication equipment. If no data is required, only signals are transmitted. If hardware data flow control is required for signal transmission, various control signals are correction approximately. Right. So request to send, clear to send. So data terminal ready, data set ready. So all keywords by this we'll come to know that what it is going to do. Right. Data carrier detect controls the signal is used to the DCI to indicate that the DTE that has a good signal is being received. So in the network also you will be observing in your mobile phone. If connection is not able, if I'm getting an echo and all those things, first thing you will observe how many points are there in the network. If it is 1 point, 2 point, you will tell my network is not good. If I observe complete 4 points are there, so my network is very good. So that signal is indicated by this data carrier detect. What is ring indicator? It is a bottom specified signal line for indicating the incoming call on a telephone line. So if any call comes, so it will indicate this value. So I hope everyone will be understanding what is the features, right? So what is a baud rate? What is the speed it will be working? So it can go up to 20 kilobits per second, upper limit of 19.2 kilobits per second. The commonly used baud rates are this. So different device will be having different baud rates which you are going to do. For my internet connection, most of the time my baud rate will be around 9600. This is common. Everywhere you will observe this one. Right. The maximum operating distance is what? 50 feet. Even if it is wire, so it can have a difference of 50 feet. Okay. So this is an example which he has given. So again same 232 is there. Then one more 422, 422, RS422, RS422, 485. So these are some other types which has been present. It is an enhanced version of RS432, 422. So 485, it is the enhanced version of 422. So what it does is that it will be supporting more. It will be having data speed higher, right? It will have some extra features, right? Apart from the regular thing. Then comes here USB part. So USB you will be knowing, right? So this USB part we will do in the tomorrow's session. Okay. You will be knowing what is a USB. So USB full form is Universal Serial Bus. So USB port will be telling, right, for your mobile phone, for your laptops, your mobile phone, not USB port, but other port it is there. I'll just tell you that figure I will show. Uh, this is a type A connector, USB port. This is type B connector, which is like a square kind of a thing, and this is your type C connector, right? So these are your multiple USB port are there. So this USB port we will be discussing in the tomorrow's class. So another 50 slides are there to complete this, and I have to complete the fourth module also, right? Fourth module half part I need to correct. So we will be doing it fast, okay, because are all general terms which are present. So this USB port we will be covering in the tomorrow's session. Okay, thank you everyone. Any questions is there? So tomorrow we will be posting a quiz also. Till now whatever we have studied till this 153 slides. So we will be having a quiz tomorrow and we will complete this USB part and we will go for the wireless communication technology. Okay, fine. Okay. Thank you.